Yes, I encourage jokes from the audience. I also encourage you to interrupt me as I go along. I'm sure there'll be a bunch of things that I say that you don't agree with or you don't understand, as there would be if I was listening to you talk. So please just, get into it. So I'll give you a little background in a minute. And I was asked to sort of address the issue of open data, which I'm actually pretty passionate about, but I'm also passionate about open source and what I would call open knowledge. So I'm actually going to sort of mix those together. I'm going to give you some background of the kinds of things that we do, not to bore you to death, but really to put it into context. And then I think, hopefully, what we actually do by virtue of open content of all kinds. So when I say content, I mean open source software, I mean open data, I mean open knowledge. And I'm actually kind of excited about the things that are possible because of this openness, and I'm just going to sort of tell you about a few of those. But let me put things in some perspective. Who here has ever used VMS? No one here looks old enough. Oh, there's a couple. All right, so I was doing IT. Has anyone ever seen this book, Unix for VMS Users? Okay, so, well, that's unfortunate, because but I actually wrote that many years ago. So I did IT a long time ago, and then I went back to sort of academia, and I've kind of dropped out. So does anyone ever remember a magazine called The Deck Professional? My goodness, oh, okay. So I used to write the Unix column for that. And it was actually a very interesting time, because Unix was a very tiny blip on the horizon of okay, but it just so happened fortuitously it was about the time that the RISC chip came out, and the RISC chip was supported by various types of Unix, and of course that sort of heralded in the scientific workstation market. Everybody moved to those desktop machines. This book sold extremely well. Okay, everybody thought I was some kind of oracle, that I predicted all this was going to happen and all this. So then people would come to me and ask me to write other books, and I wrote actually 2 or 3 other books. One called A Cookbook for Unix, a cookbook for the internet, not cookbook, was it called? Yeah, Cookbook for the internet, the Unix version, which sold abysmally, because by the time it came out, it was totally out of date. So my period as an oracle only lasted for a very short period of time. But there you have it. I was also asked by Prentice Hall to write a book about the web around, I don't know, 92 or something, when it was just emerging. Ed Kroll then wrote a book called The Whole Internet Guide, which sold a ton of copies. So I blew that as well. So there you go. So maybe that's why I went back to doing research. So as I heard when I came in, I thought, oh, there's someone else here who does computational biology, but it's actually, he was talking about me. So I'm involved with various open projects, which I'm going to tell you a little about. We distribute data free, scientific data of various types. I'll get into that a little. Right now, we're distributing about 1/4 of the contents of the Library of Congress every month. So we have a whole bunch of servers here at the San Diego Supercomputer Center, which is like, for you folks, it's probably like, as it was for me at the time, some incredible toy shop. There's also Cal IT 2 here, so there's lots of really interesting stuff. I haven't written a line of code. I can code in C++. I started in Fortran. Everything in my lab is now in Java. And I haven't written a line of code for 10 years, because there's absolutely, I have 25 people or so in my group. Everyone in the group can write better code than I can. So that's sort of the perspective I'm coming to you with this. What we do, all our software is sort of open. So when I say that, we have constraints by the University of California system, which I can say, even though I'm being recorded, actually really sucks. And we're actually working to address that. There's actually co-chairing a committee right now on behalf of the University of California system to look at how we interrelate with industry. And part of that, of course, relates to IP. So hopefully some changes will come out of that. I got involved with the Public Library of Science, which I'll tell you about. That's an open access environment, and we'll talk a little about that. I have a company that's sort of a disclosure that's trying to not make a lot of money, but it's trying to sustain itself. And to me, this is an important aspect. And you can contest what I have to say about this, but, and I want you to. But you know, what you'll hear from me is it doesn't matter what you're doing in the open space, there has to be a business model. To me, it's no good producing something, I'm already getting ahead of myself here, but it's no good producing something if, you know, you can't sustain it. I mean, in some cases, the open model can be you as volunteers. That is the business model. And that works sometimes, it doesn't work all the time. And so if you want to produce something that's sustainable, then, you know, there has to be a way of doing that. And of course, my views come very much not from a global perspective so much, but where I spend most of my life, which of course is in the biosciences. So right now I'm going to give you the take-home message. When you get through this workshop in a week or whenever, however long you're going to be in sunny San Diego, and by the way, welcome, that if you could remember 3 things that I said, I think it would be great. So here's just a little help for those 3 things, essentially. So I would say openness has got nothing to do with content type. You might be doing open source software. We do open data. We do open knowledge. So those different content types. I said about the business model. And, you know, I think what really excites me is the idea of using it to actually create new ways of learning and comprehension. And I'm going to give you some examples of what we're doing to achieve what I hope is achieving that goal. So that's, you know, so if you've got bored already, if I'm droning on, you've got the message, you can go out and play in the sun for an hour and then come back. So let me just tell you some of the things that motivate me. We have a dry lab. I have no, we don't do anything with terrible chemicals and things like that. And certainly we pretty much operate on open source code. So at my lab and all the science we do would not operate without the kinds of things that you're doing. So we're infinitely grateful of that. I maintain a large database called the Protein Data Bank, and these are just examples of proteins that come from it. There's not a drug that's been discovered in the last 20 or 30 years that hasn't in some way used this data. Okay, so it's actually very important. It's free, but you know, we get a significant chunk of change from the federal government every year to sustain this data supply. And essentially our obligation and our charge really is to deliver that data free and accurate and as accurately as possible. So these are continuing to do that and really giving, you know, the taxpayer value for their money is something that is really a driver here with data. What motivates me with knowledge is there should be no bounds on knowledge sharing, okay? So the problem right now is the majority of business models around knowledge, certainly in science, are all for profit models. And as you'll see in a minute, I think they really impact things. I go and talk to scholars in developing countries, and it makes me really sad that for a number of reasons, they don't have access to knowledge that's in, say, for my particular interest, the scientific literature. They just cannot afford it. Now, publishers do cut deals for developing countries, but even so, they still, for the most part, can't afford it. And all of these things are integrated together because, as you'll see, in working in open access environments, as I do with the Public Library of Science, we produce a lot of knowledge in journals that's free to read. But it still doesn't mean those people can get access to it. If you look at various parts of Africa, those people, you'll have institutions that might have a reasonably good intranet, but what they don't have is they don't have good connectivity to the outside world. So even though the stuff might be out there on the internet and free, they still cannot easily get it. But ironic things change that. Right now, for example, they're putting in a broadband connection, a large broadband connection all across Africa, only because they're having the World Cup there in South Africa, I guess, this year. So however it happens, it's happening. So that will reduce some of that disadvantage. So let's look at this history through examples, some open software and knowledge, and then see what we can do with these things today. So let me just lead you through a bit of history around some of the things that we've done with open software, with open data, and with open knowledge. So the area I work in, there's been a lot of open software around since way back in 1980, when it used to be actually distributed on reel-to-reel tape and all this kind of stuff. but I was involved with a project called the Collaborative Computational Project, and there are a whole series of these that were funded originally by the British government, now by the EU, and they still go. And they've actually had an enormous impact on those scientific communities. And so it's, it's basically a code-shared base. And there's a lot of other things that go around it. There's meetings, so there's a lot of knowledge exchange that comes by virtue of having that software base. Then there are other projects, many of which you probably sort of know about. There's BioPerl, BioJava, so that in the life sciences community, there are significant open source efforts to actually around different languages and so forth. And then I'll tell you just briefly about something that we do called the Molecular Biology Toolkit, because I think it represents a sort of shift in the way that people think about producing open source software in science. So essentially, here's an example, is that there's been a shift. I think early too much emphasis on open source was just in providing end-user applications. And I'm speaking really for my, my own biosciences. What's happened now is I think it's shifted much more towards foundation toolkits which can then be built upon to build applications. So just as an example of that, something that I do a lot of is molecular graphics. There's a whole bunch of programs that were developed, all open source, RasMol, JMol, PyMol, all the moles you can imagine. But basically, they all do very much the same thing, and they basically do it in terms of producing a final application. Now, that's not what a lot of people want. I mean, because this doesn't do the job completely, this doesn't do the job completely, this doesn't do the job completely. So what we've tried to do is essentially, over a number of years, it was hard in the beginning because the technologies and the languages, from my point of view, weren't there to do it. But I went through the whole era of, particularly with databases, which was somewhat disastrous, but of object-oriented databases and object design principles, basically, that have become easier and easier and now obviously really pay off. And anyone in this room knows much more about this, what I'm saying, than I do, but you get the idea. So this is just a sort of structure of the kind of toolkit that we built to do not just the kinds of molecular applications you saw, but that someone could take and basically modify and use to build a whole series of applications that really are selected towards a specific user base. I mean, unless they all kind of look the same, so that's just unfortunate. But here is an example down here on the bottom right that's actually designed specifically for immunologists, and they love it, okay? But this wouldn't work for them, what was here, all these generic tools. They want something specialized. And basically, essentially they're only working at this application layer to produce new types of applications for new user types. And I'm sure these are all things that you think about. But to me, that makes a fundamental difference. So what about open data? So here, I think the important thing, particularly in the life sciences, is we are actually absolutely awash in data, okay? You know about the Human Genome Project and all these kinds of things. That is just the tip of the iceberg. So this is this data resource that produces these three-dimensional structures of proteins and other biological molecules. And all I want to illustrate here is that basically this data is free and that essentially it's grown very rapidly, okay? So what the capabilities have increased dramatically. And then what's also happened is it's become international. There used to be a big sort of contention because it was run in the US, and the Europeans and parts of Asia really felt that they were contributing to it. They ought to have an equal say in its operation. So it's now called the Worldwide PDB, Protein Data Bank, and in fact it works very well across nations, and there's a lot of interactions. So let me just tell you about how it happened. So why is this data free, and why does this work as it does? And it basically came from a grassroots effort. It came from the scientists themselves saying, we must do this. We must preserve and make this data available for next generations. But, saying it and doing it is two very different things. And the way they got it to happen is they basically got all scientific journals to actually commit to the fact that they would not publish papers on using this data unless the data was in a public repository. This was a huge thing, because if you're a scientist, you know, you've heard the term, I'm sure, publish or perish, and basically that's what it's all about. And unfortunately, it's becoming more, as you'll see in a minute, more like that every day. So the drivers are to actually, you know, to get people to publish, but if you can't, if the journal won't accept your article unless you put the data in an open archive, that's what happened. And we're seeing that across the same model, as this was actually the first to do this, but the same model is being repeated across many scientific disciplines. So where it leads to actually a lot more open data. The other thing, of course, is when you get growth of data like this, when we were down here in the 70s, to actually do one of these structures, one of these blobs here, was a life's work. It's now a week's work. So the value of that data is perceived quite differently. So that in itself also makes things more open. And I think by virtue of what you've done with software and what is going on in other realms as well, particularly, I mean, I think the general openness, the Web 2.0 and everything else, and communication is just pushing us all in this same direction. So it's actually a very exciting time, I think. And I'll get to what you can do with it in a minute. So what about open knowledge? So this is a bit that I like a lot. Because you'll see that I'm kind of quite anti STM publishing, which is science, technology, which includes what you're doing, and medical publishing. And part of the reason is this. If you could take any libraries, this is sort of a generalization, but you could take the library budget here at this university, and what you'll find is that the amount of money we've been putting into the over the years follows this red curve, essentially. What's also happened is that the number of journals we purchase has just essentially remained flat. So I would argue that scientists, and essentially unbeknownst to them, have been gouged by publishers over a number of years. Okay? Finally, some of us woke up. Okay? We're very slow. Okay? This was going on for a long time. But in 2000, and partly it was instigated by well, various people, but particularly someone like Howard Varmus, who is a Nobel laureate, the former head of the NIH, and the founder of the Public Library of Science, which I'll say a little more about in a minute. He's now also an Obama advisor, a science advisor. But basically with his and a number of other Nobel laureates and other people's instigation, 34,000 of us signed this open letter to science and medical publishers saying we were dissatisfied with the publishing model. And so what's happened is that increasingly we've gone from a closed model to an open model of publishing, so in other words, an openness in making knowledge available. And the way that works is, instead of the traditional business model where the reader pays to read the material, in this model the author pays to publish it, and then and it's published and it's peer-reviewed, and the whole process is the same, because all of that's done for nothing by scientists, okay, out of a commitment to what they're doing. And then it means when it's published, it's actually free for everyone to read. Now the key, as you'll see in a minute, is it's not just free to read, but it's free to use and manipulate. And that's really the key. And there are a number of publishers. So even the most traditional closed publishers have now been forced into this model of, at the very least, what's called a hybrid model, where you can publish either as a closed or an open article. Okay? And the Public Library of Science have been proponents of this. And then the NIH and the government agencies, not just the NIH now, Burroughs Wellcome in the UK and so forth, Howard Hughes Medical Institute, all these places, basically put forth a mandate that if we were using the public's money to do research, the public should be able to read the results of that research. Seems pretty fair to me. And so that's had a pretty profound impact. Oops. Okay, so I think what also, when scientists started to it's still a slow process, but I think as scientists started to realize the importance of this, more and more people have got on the bandwagon. And it's really, just as there's a group of software developers doing the, sort of making software available in an open way, now the work that these scientists are doing is also being made available in an open way. So, okay, that's a bit of the history of respect to software, data, and knowledge from my naive and limited perspective. So then the question becomes, well, what can we do with it? So I actually, because of my involvement, I actually run a journal for the Public Library of Science called Computational Biology. And because of that, I started to see the promise of what could be done. And as a result of that, I actually now have a sort of, not all of these people, but a subset of these people who work in the area of scholarly communication. And by virtue of the openness of that material, we've actually been able to do a few interesting things. And I wanted to just tell you a little about them. So the basic big picture question we're trying to answer is, or two questions really. Can we improve the way that science is disseminated and comprehended? And through openness, can we increase the number of people interested in science? So that's kind of our mantra for this. But I think what makes it easier for us is that we're starting to see a sea change in various ways. And the formation of the Public Library of Science and so forth is one example of that. But there are others. And so I think we're in a mode of rapid change. So what are these drivers of change? Okay, so let's look at that a little. So scientists are very busy. Not only are we actually seeing an increase in the amount of data, we're seeing increases in the amount of knowledge that's being produced. So in the last 15 minutes that I've been talking, and you've been sort of listening, 150 papers have been, no, maybe not now because it's Saturday, but 150 papers have been indexed by PubMed, which is an aggregator of abstract content for the biomedical sciences. Okay? So, papers are coming every few seconds, basically, from some scientist somewhere in the world. It's an astronomical growth rate. So and this sort of illustrates that. So basically what we've seen is that, right now in PubMed, this repository for this information, we're getting about 1.2 million papers a year. So that's a lot of reading, I shouldn't be here talking to you. I should be home reading papers. But I'm not. And you can see that sort of from this graph. I'm doing a bit more reading. So the number of articles I read per year is now about 450. So that's like, 2 a day, basically. Assuming I take a bit of time off here and there. Do something interesting. But the amount of time I spend on a paper is dropping off. So I need new ways of accessing information. And the fact that that information is open means, if it is open, means that the ways that I can access it are way improved. And I'll try and prove that to you with a few examples. So what's happening is we're being forced into this mode of being writers and not readers anymore. Okay? That's one thing. And when we do write, so we're all obsessed with publish or perish. There's this thing now called an H factor in science. And the H factor, with an H factor of 30, it means I have 30 papers that have been cited more than 30 times. It doesn't say, we say to yourself, who cares? Well, basically, people are losing their jobs in various institutions, not in the US, but in, say, in Europe, particularly in the UK, if their H factors ain't any good. So, there's a heck of a lot of pressure to do this stuff. But at the same time, we're actually writing in different media. And I think this is really exciting. So, more and more scientists are blogging and doing other things, which I'll get to in a minute, because I think it opens up a lot of opportunities. And of course, the internet has changed everything. Okay? So basically, in '93, there were very few electronic journals. By now, pretty much everyone is online, but a number of them also still have hard copy. The business models are such that hard copies, in my estimation, will be gone in 3 or 4 years. There's just no way that a journal is going to be able to sustain itself by putting out printed copy. And really, who cares? It's not. It is because the old fogies. I try and say I'm not one of them, but I am, at least by looking at me, but hopefully not inside my head. Is that they still like that notion of holding that that thing, that journal. You know, you can take it to the bathroom, you can do whatever you want with it, right? But I think that's going away, partly because it's just much more convenient to sit there at your desk, and partly because the idea of having all the things you need to know in one journal is no longer the... Oh, blimey, what do I do there? Uh-oh. Oh. So basically, you know, we need this kind of access. However, what's happened so far, which I think is pretty abysmal, is that most publishers, all they've been able to achieve is to use the internet as a distribution medium. They haven't been able to really embrace the excitement of the medium to improve the learning experience. And, you know, again, I'm going to show you a couple of examples where I think we're improving the learning experience, but only by virtue of the fact that things are open. Okay? So I keep coming to that. And of course, it embraces Web 2.0 and Web 3.0 technologies. I mean, that is really the key to making this happen. So what are these responses to change that I'm sort of alluding to but never really telling you anything interesting? First of all, the traditional publishers are worried to death. They're basically starting to lose the massive amounts of money they were making. So we talked about these alternative business models. Societies, you are essentially a volunteer group. You come together, you do stuff. That's fantastic. That's kind of how society, I'm going to get creamed for this, but scientific societies started off. But what I have observed, having been close to the beginnings and founding of one, and seen other big ones like the American Chemical Society, is very soon they essentially become businesses in their own right. And they have, you know, I think they lose a lot of that volunteer flavour, and they worry about stuff. So the problem is, of course, a lot of these societies depend on the journals for their revenue. And if you have an open access journal, you lose that revenue essentially, because the best you do is break even. So, you know, it affects societies. The other thing is, you know, when I was the age of most of you in this audience, when I started, society was important to me. It put me in contact with other people who had similar interests. It basically allowed me to go to meetings. It allowed me to read the journals. It helped me find a job. I don't need most of that anymore. I have monster.com. I have Facebook, you know. So societies really need to reinvent themselves in this world. The other thing that's happening is that journals where the knowledge has traditionally been held, and the databases where the data from which that knowledge comes, the distinction between them is blurring. And I think lots of exciting things can happen. And I'll get into a little of the technology of that, which I'm sure, you know, to how we apply that. So let's start with open access. I think that open access to the literature can broadly change the way we do scholarly discourse. And I'm going to show you examples of that. But it's still a big if, okay? So I think we've yet to have the killer app. You know, I don't know what the killer app is in open source. Maybe it's Linux, I don't know. But basically, we don't sort of have that killer app yet in open access to the literature and to the knowledge. But, you know, I would love to be the person involved in creating it, or one of the people involved in creating it. That'd be a lot of fun. So essentially, what we have, this actually illustrates the growth of the open access literature. And in fact, it is, you know, it's growing. It's not growing anywhere near as fast as the literature as a whole, but it is starting to gain momentum. And not necessarily because we're all good-natured citizens and we're publishing open access. It's basically, we do research, we get money from the government. The government won't give us that money anymore unless we actually make our stuff open. So everybody's rushing to make it open. So it's creating that change. So that's a good thing. The key to all of it is, and this is something that I'm sure you face with licensing and so forth, is how you actually license the material. And in fact, even though some journals, some knowledge is called open, you know, there's some knowledge is more open than other knowledge, okay, by virtue of how it's licensed. So, for example, in PLoS, it conforms to a Creative Commons 3.0 license, which is basically these three rules here. So it's basically, the information's available online, it's free to all. The copyright remains with the author, And then I think the key to the future is that there's unrestricted access to this material in various formats, including marked up formats like XML. And you can use it in any way you want, provided you give attribution to the original authors. That creates enormous possibilities for knowledge manipulation and furthering our understanding of that knowledge. So that's what can be exploited, I think, by virtue of this license. But different people publish this, in the way there's a 2.0 license, so you can actually use it, but not for commercial purposes and all this kind of stuff. Also, there's elements of openness where a journal will actually make their stuff open, but all they produce is a PDF. And that's a lot harder to deal with than trying to deal with some XML that conforms to a well-structured document type definition. So assuming open access takes off, what's possible? Okay? So clearly you could start to do things that you couldn't do before. You can do mashups. And let me give you an example of a mashup. Okay? So I walk into my lab. This is stuff that we're doing. I walk into my lab and I see 4 graduate students sitting there, all wearing headphones, avidly working away. And I'm thinking, this is great. This is the way it should be. I'll go and go have a beer while they're doing all the work. Then when I look more closely, and you can see by the surprises on their face, they weren't that happy to see me, they're all looking at YouTube. So I start thinking, this is about 4 years ago now, I suppose, and I start thinking to myself, why, if they're doing it, why aren't we making better use of it? Why don't we, can I learn science from YouTube? I can learn a lot of things from YouTube, but. And I looked around, and yeah, there was some interesting content. But then there were other issues, okay? So the first issue was, what do you do when you go to a new website? The first thing you do is you look up yourself, right? So I made a video for this place, for UCSD, and I typed in my name in UCSD, and up popped on YouTube. There it was, my little thumbnail with me. I could start playing whatever I'd said. But then I looked more closely, and immediately underneath it, there were 4 nude guys standing there and with their own thumbnail. And then when I looked more closely, it was some Austrian dance troupe of nude dancers, one whose name happened to be Bourne, right, which is my name. So I'm thinking, well, as a scientist, I'm not necessarily sure I want my content mixed in with this kind of content. So that was one thing. The other thing I thought about is we could do much more than is currently possible with YouTube, okay? And that's what I'm going to tell you about. So we developed a resource called SciVee.tv, and you can go there. This is just the address. These are a bit old slides because it looks a bit different now, but the same kind. It's a Web 2.0 resource built from Drupal and MySQL and so forth. And basically, it does some things that you can't do with YouTube. So what it does is it mashes things up. So I can take an open access paper and a video I've made. So typically, when I'm sure you've read. Even if you don't read scientific papers, you read technical reports and other things. So basically, typically there's an abstract, and that might take you a minute to read. And then if you're interested in the content, then you have to dig into the whole thing. And that could take you, depending on what it is, but for a scientific paper, it could take you 3 hours. Okay? So what we thought about is let's put the author in the middle of those 2 time frames, get them to make a 5 or 10 minute sort of synopsis video of what they're talking about, and synchronize that with the paper itself. So when they talk about a particular element of data or a particular feature of that paper, that part of the text or a table or a figure pops up so they can see it in the context of what's being said. So you've got traditional content in written form integrated with video in a mashup. And that turns out to be quite an effective learning experience. And we've tested this, and students seem to like it, okay? So basically, and you do it all online. So essentially, you load your video, you load your paper, and basically you just run through the video and you synchronize it by dragging across bits of the paper. And you can do that through the website. So, it works pretty seamlessly. You can play around with it, if you do it now, but to keep the sound down. So you could imagine sort of how this works. So first of all, you're reformulating the paper. The paper is being presented in these tabs and in other ways that weren't present in the original article. The only reason I can do that is because this is published under a Creative Commons 3.0 license. It's completely open. I can add this, what I believe is adding value to it. Okay? People can also come in a typical Web 2.0 environment and comment and rate this material in ways that's not possible traditionally in a scientific journal, although that is beginning to change. So the way it sort of works, and I might be just an old fogey and I just prefer reading stuff on the screen, but I'm reading something and what's he or she trying to say here? I just don't quite get it. And then what you can do is basically click on that text and up pops the author and starts telling you explicitly about that piece of the paper. And hopefully that helps. So it's an example of putting these things together by virtue of having open access that would not otherwise be possible. I keep rambling, emphasizing this, but you get the message. Of course, part of it, you can go there, just like YouTube, you can watch whatever you want, you don't have to sign up. But if you want to comment or you want to actually upload something yourself, you have to sign up. So then falling out of this is a whole social network or a professional network of scientists talking around this material. And so they're talking around these particular types of content, which is turning out to be moderately successful. But I went to try and sell this idea to various people, including venture capitalists, and no one was really interested. So we're kind of doing it on a shoestring. But basically, one of them said to me, they said, you've got this idea, but I don't think that in and of itself will make a decent company. But I think other things will happen that will actually, that you don't even imagine right this minute, that will actually drive this thing forward. And in fact, that's, as many of you know probably better than I am, perhaps some of you are part of them, there are companies, internet companies particularly, that have proven this time and time again. They end up doing something completely different than what they started out doing, and sometimes few times they're successful. So it turns out that doing this with scientific papers doesn't work as well as we would like, because by the time the paper comes out and you can do this, the scientist has moved on, they're thinking about other things, and to go back and promote that work is it's a bit of an issue when you're actually trying to do new work. On the other hand, many of us go to meetings, and perhaps you've done some of this too, where there's posters, okay? You go to a meeting, you take your poster, you get on a plane anytime, or you're trying to quickly get through security and there's someone with a poster in front of you, and that can slow things down, all right? So you see posters all the time, you see them at meetings, and essentially they're up there on the screen up on a poster board for a day or two, and then they're completely gone. What this enables you to do is to make them more persistent. So basically, it's integrating material, you're integrating video, in this case, not with a published paper, but with a poster, another piece of open content. Not everybody wants to do that, but some do. And that's what this is what it looks like. Things that we never imagined. Video is now a very important medium all around, obviously, and particularly in science as well, because there are many things that happen are much easier to understand when you look at them than when you read about them. Imagine a complicated scientific experiment. You go to a paper and then you've got a materials and methods section, which is just just boring as hell to read, and often you just don't get it. If you watch the person doing and describing the experiment, voila, it's a different experience. So clearly these kinds of things are important. We're doing a video competition now, so with Scientific American, because they're trying to promote this kind of thing as well. You can do it with CVs, you can do it with all sorts of stuff. With posters, basically, here's someone talking about their poster. You've got the typical kind of rating system, all the rest of it. And the green bars across here are basically the synchronization points. So as they talk, first of all, you go into full screen mode, you get the poster here, and you can't necessarily see, but you can zoom yourself if you want to. Or, as in this case, he talks, the parts of the poster he's talking about zoom in and you can see exactly what's going on. So you're getting this kind of contextual idea. So this, again, is just by virtue of people being open in this case with their posters, this is the kind of thing you can achieve. Okay, so what else is possible with all this? Well, I think the issue of semantic tagging is an example. And so here's the idea is to tag existing materials, okay? Again, if the scientific literature is open, you can tag it and increase its value, if you like, okay? So you add semantics to it, and you can do that. The first, and here's an example, if you care about this stuff, you can go and look at it. But basically what's happened here is that we've taken the contents of the open access literature and we've post-processed it against a whole series of ontologies, which are semantic descriptions, if you like, of things in our field, and also references within these papers to databases and database entries. Okay? So, and what you see, so this is a reformulation of that same paper, but here you actually see all of the ontological terms and how often they're used in the paper, how many database identifiers which describe data that's related to what's written in this paper. So you've added value by post-processing it against these ontologies. Okay, so that's, again, only possible with the open literature. So this sort of illustrates that. Here's an example where you mouse over a figure in the paper, and that basically has been tagged to the contents the data that actually was used to generate that figure. When you do that, what happens is there's a web service call that goes from this formatted page out to the database that contains this data, which has an API appropriate for recognizing that call, and basically stuff comes back. And so you don't leave the context of what you're reading, but you're actually learning new things by pulling in effectively data from somewhere else. So in other words, this paper has now become, in a sense, an interface to a whole set of open access data and other types of content. So this undoubtedly, I think we've tested this well enough, enhances the learning experience. But we're doing that after we've got the literature. So that is not the optimal situation. What you would really like is you would like the author who's writing this material to be the person doing the semantic tagging, because one presumes that they know it better than anyone else. But the first question is, well, what's the incentive to do that? Well, the first thing is you have to have useful tools to do that. And probably what I'm going to say now, most of you, probably everyone in here except me, won't like. But we actually have done this, and we made a plugin for Word. And Microsoft actually funded this. The plugin is open source. Obviously, from Microsoft's point of view, the idea is to sell more copies of Word. But from my point of view, most people I know are using it already. So if we can enhance the value of that use for free, that's good. So basically, there's a plugin so that you can actually do this, facilitate. I won't go into the details of this. It's all in this Codeplex website if you want to look. Basically enhance the value of that document as you actually author it. And that's been, I'd say, moderately successful. And also you can actually use it to help define new ontologies and all that kind of thing, but I won't get into that. But essentially what you can imagine what it's like is it's like the spell checker in Word. Probably no one here uses Word except me. But anyway, so basically, it'll offer to auto-correct things. I actually type I type a term. Let's just say it's a common name for a taxonomy. I type in human, and basically it comes back to me and say, do you want to say Homo sapiens? And I can then say, go away, or I can say yes, or I can say, well, sort of. I want to say human in my paper, but I want you to semantically tag with that term, Homo sapien. Now, that is important because that then provides a hook in the literature through a systematic name that I can use, because ultimately, the systematic names, this is a trivial example, are used throughout of science. So I can actually start to semantically connect things by virtue of using the appropriate terms that I couldn't do necessarily with common names. That's a trivial example. We deal with these esoteric gene names and things. So someone discovers a gene, they name it after themselves. Well, that's not particularly systematic, this kind of stuff. So you can get the systematic meaning. So how do you get people to use this kind of stuff? Well, again, it comes back to the publish or perish. People aren't going to use it unless a journal says, okay, if you semantically enrich your material, so this would take us, I suppose, towards the semantic web, whatever that is. You can tell me afterwards. Basically, but no one's going to do it unless there's a reward for it. There's got to be a reward. We're going to talk about rewards in a second, okay? You get a reward for being here because it makes you feel good or something. I don't know. I'd be interested to know why you are here, but and I'm sure it's not here to listen to me. But anyway, I accept that. But you know, there has to be some kind of reward, even if it's not just, but even if it's a good feeling. In this case, you know, if it's in a publish or perish world, if the publisher says, well, if you semantically enrich your paper in this way, we will fast track its publication, I guarantee everybody would do it in no time at all. So we're kind of on the verge of that point, I think. So that's really what it is. So what are the other responses to this sort of change? So I think we've got open literature and we've got open databases. And this is sort of what goes on in our fields, which perhaps might seem rather silly. So more and more journal articles are basically, they have this fixed format, and then they have a whole bunch of supplemental information, which more and more is including open data. The problem is that data is not structured in any way that's really useful by a computer. So, you know, it's just craziness. At the same time, there are databases that are funded by the federal government, which are very important for various purposes, including the one I do, where there are a bunch of people sit in a room and read that literature and translate it into the database. They're called biocurators. They have their own society, and you know, they do a very valuable job. But why on earth do we have to go through that whole process and spend all that money effectively twice? There must be a simpler way. So we've been, you know, the idea here is to map open literature with open data. And essentially, this is just an example of that. I won't go into the details of that because you probably don't care. But essentially, this is a database view where we're pulling information out of the literature and contextually speaking with a bit of text mining and including it here. So it's actually adding value. So rather than the person looking at this having to go to the literature and do all this stuff and try and figure out what's going on, it's essentially done automatically, only because the literature is open access and fully online. Then there's this other view. You can't read any of this, but I don't know what I'm talking about, but I've become, and so you can contest this, and I'd be very interested in what, but I just wrote this editorial for the journal I do that, you know, and it was basically titled, Will Widgets Change the Way That We Do Computational Biology? So I've become enormously enamored with widgets. Not that I actually have written one, or, you know, but what gets me is here's a piece of text. This could be out of the literature, and here you can't read any of it, but here are, each one of these essentially represents a very simple widget. And what, from my point of view, what I can, there's two reasons why I think it works. It's very important. Because firstly, it's dead easy to do. Even I could do it. I'm pretty sure I could do it in no time. And it adds a lot of value. So what it does in this case is, here's a piece of text. So essentially, I can mouse over a series of that. You could go there and play around with this stuff if you can be bothered typing in that whole URL. If anyone's interested, I'll post these slides and you can poke around. But basically, here's someone's name. When I mouse over that name, it makes, you know, it uses this widget that basically interacts with the API of our database and will actually provide all of the information in the database that's ever been done by this person. So it's just, again, I can pull that up without leaving the context of the article. I can actually make queries of databases by virtue of what I'm reading in this text. So I can do a whole series of things. There's, you know, there's actually a Mac desktop widget, all this kind of stuff. So I think, and now what we're starting to see are widgets that actually do computation. So the idea is that we're not quite there yet, but it's sort of extending, we're working towards extending the kind of iGoogle concept, where instead of just having a bunch of widgets on a page from different sources in computational biology, we basically have, they're basically the same kind of thing, except we can put them into workflows. And so people can, you know, easily on a web page build their own workflow to actually access a whole series of biological resources that are free on the web. So that to me seems, maybe this is old hat to all of you, but to me, and it's something that scientists aren't doing yet, but it's clearly going to happen. I mean, I just feel it. At least that's my opinion. So when you put all this together, here's a sort of scenario that just summarizes this, and then I'll get off this topic. But I'm reading an article. It could be something you're interested in, a technical report. And then there's a figure in that article. It could be, you know, from your point of view, it could be a piece of code. It could be this. It could be a flow diagram. I don't know what it. For me, it just happens to be this molecule. But that's almost the worst way of understanding what's going on there. What I want to be able to do is click on that figure, and that figure has a set of metadata associated with it, which actually pulls data from a database, actually displays that figure in a way that I can then move it around on the screen. I can look at it in different ways, okay? And you can imagine in your own context how that was useful. Then I can annotate some of the information about that figure that I want to remember. I can store that, so next time I bring up this paper, it associates with my annotations. And then, of course, that may actually drive me to a mashup. I query this figure and pulls up some data that's a combination of things from the literature and other databases. That makes me go and read another paper, and off I go. So these are sort of enhanced ways beyond what we can do today, at least I can do, to actually improve our comprehension of the material. And here, what's interesting is then, if you remember, I said there's 1.2 million papers being indexed a year now in our area of science. I can't possibly read one tiny fraction of those. But here's an example of how I can exploit that literature if it's all open and it's online, okay? So it doesn't matter what these things are, but these are basically elements of data, okay, that are in this, I scour the literature and I find references. Each of the nodes in this network is a reference to a piece of data. Now, what's here, this edge, means that these two here have been found in the same paper, in the same piece of scientific literature. Now, you can't see very clear here, but the thickness of the edges means the thicker the edge, it means that the more that these two have been found together in the literature. So without ever reading a paper, I can actually generate these kinds of graphs. And it just so happens in this case, all of these were in the immunology literature, okay? All of this over here was in the cardiac disease literature. But there was this intersection. And the chances are it may be that this community of people interested in cardiac disease were not even aware of the immunological implications of this piece of data. So all of that comes from just by having open access to the literature and being able to mine it. This is just a fairly trivial example and a promise of what's to come. It doesn't matter what. So let's look farther into the future, okay? So I'm about to finish in a minute, so hang in there with me. Sorry if I'm boring you to death. So this is what we do. This is our workflow. We write grants. We then get to do a poster. We do journal articles. There's different people involved in that process. And what's started to happen is that what's happened for a long time is we've always written reviews. So we review other people's papers, other people's grants. We don't get any reward for that, okay? We do that as good citizens. We do community service, we deposit data, we curate data, we write blogs. We don't get any reward for all of that. It's not recognized, okay? So if I'm on a tenure committee, and I say, we should give this person tenure because they've written a whole series of very interesting blogs, you know, the rest of my department is going to look at me like I'm another planet. Some of them won't even know what blogs are. But, you know, that's very slowly is changing. And I think we need to be prepared for that change. So in some ways, maybe you don't care in what you're doing here, but these people care. Whatever they do, there needs to be a way at some point of getting a reward. So at some point, I want to press a button. I want to take anyone in this audience, and I want to immediately establish what has been your collective intellectual output. What is your scholarly product? Okay? And that's going to be all of these things around this graph here. To be able to do that, the very first thing I have to do is I have to be able to identify you, okay? And there lies a problem. Particularly in cyber, everything of this is going to be in cyberspace, and we need to be rewarded, but it needs to be, you know, attributable. So we know, who knows what a DOI is? Just give me, okay, a few of you. So DOI is a digital object identifier. It's essentially assigned to individual pieces of scholarly output, typically a paper, as an example. And essentially it can be resolved. There's an organization that provides a resolver. All publishers use them, so you can get to the unique and original source of that information. So it's a very powerful tool in cyberspace. So what I'm suggesting is we need a DOI for people, okay? So we need to be able to, because we need to disambiguate you, okay? And this is important, even in my own case, all right? So I wrote this book about Unix in 1990. Does anybody know who this is? God, you Unix guys, come on, girls. Who of you have used the Bourne shell? Okay, well that's Steve Bourne. He wrote the Bourne shell, okay? So when I wrote this book, everybody thought I wrote the Bourne shell. Okay? And if I had $1 for every time someone said that, I wouldn't be bothering standing here. That's not true, I'd be here anyway, but because you're such a jovial audience. But anyway, it's about disambiguation, okay? And here's, you know, my own scientific point of view. This guy here does much the same as I do, but he's Philip C. Bourne, I'm Philip E. Bourne, okay? So in a lot of ways, we are not disambiguated, okay? If I go to certain sources of information, I wouldn't be able to tell the difference between him and me because it's his first initial and we do something similar. So I actually wrote, we need the Bourne identity, okay? This is what I want, all right? And I actually wrote an editorial about this called I Am Not a Scientist, I Am a Number. And I wrote this in a journal, in my own journal, which allows commentary on articles. And I'm telling you, it got a lot. There's a very passionate set of alternative views about this sort of stuff. You know, and you know, in the end, how many of you here watched The Prisoner? Have watched The Prisoner? A few of you. So basically, it's a great. They just made a remake of it, which was pretty crap. But the original was fantastic. In fact, I don't know if it was fortuitous. It was a terrible thing that happened, but the day that this paper came out, he died. So that's Patrick McGoohan, who used to play the prisoner. And he was basically in this place. He didn't know why he was there. And he was always trying to escape. And you know, basically, everyone there had a number. And there's a great scene. It's on YouTube. If you go to this link, I'll give you the base of describing this. Maybe should I show it? What the hell? Oh, yeah. It'll show you how wacky this is. I think you're the kind of audience who would appreciate this. I can see. Let's see if I can bring it up.